Hello everyone. In today's video, I'm going to go over the packet on optics mirrors. We will be using some of these equations later on in this lab, so we'll go over those first, and then I'll walk you through some of the labs, show you the videos, which tend to help. So make sure you're clicking all the links that are available to you in the labs to try to give you a better understanding of what you're supposed to do. So this first one here, let's start with F. We've seen this F before as frequency, but that's not what we're using it for here. Here, this F is the focal point. Okay, so that's the point at which our image will be focused. All right, it's where our light rays are going to come together and make a focal point. Okay, and the focal point is going to be at some distance from our mirror, so the focal point is going to be measured in meters. Now, since this is a distance, it's going to have to do with the distance our object is from the mirror, and that's what SO is. It's the distance of our object from the mirror. And that will be measured in meters. And then SI is the distance of the image. And that is our reflected or our virtual image that we see, and that's measured in meters as well. All right. So then next down here we have M, and this M is our magnification. So that determines how much bigger our image is going to appear. Compared to the actual image. Okay, so magnification, if we look here, we're dividing. Okay, we're dividing the height of our image, so the height of the reflection, the image that we're seeing in the mirror, which is in meters. And then we're dividing that by the height of the object. And the height, this will also be in meters. Now, units for magnification. If I find magnification by dividing meters by meters, those meters would cancel out there, so there's no units for magnification. The other way of looking at this one here, the inverse of our image distance divided by the object's distance, another way to find magnification. Okay, so now if we scroll down here, again, these the checklist for this chapter, it's everything, not just for this set of labs. Here's a bunch of computer simulations. And then here our first one. So reflection on a flat mirror. So this is probably the one you guys are most familiar with. If you have mirrors in your house, bathroom mirror, things like that, it's a flat mirror. So if we click the link here, it brings you this the physics classroom. And if we pop open this here, we have two different activities to do. The first one, it explains how light rays reflect. Shows you these angles here, and the normal, so the perpendicular line coming off the surface, and how a light ray coming in will bounce off at the same angle. It explains all that. The other one here shows you how images form in a mirror, which is what's going to be helpful in this first part of the lab. So if you get to the end of this second part, it starts showing you what words would look like reflected in a mirror. And once you have that down, come through and tell me what would the word mom look like, what would the word dad look like, what would the word Dornfeld exclamation point look like in the mirror. Okay, for this next one, it's an exercise in understanding the angles of your images. So before I maximize that, okay, who can see who? So Bill sees who. So if we look down here at the bottom, here is Bill. We want to know who can Bill see in this mirror. And it all comes down to angles. So who can Bill see if we click there? Or I'm sorry. Yeah, Bill sees who. Okay. So if Bill was standing here and looking in this mirror, if you looked anywhere on this mirror, who would he see in the mirror? And if you click on a person, like if I click on Alan, it shows you that Bill's angle toward Alan is over here. It's not on the mirror. He can't see Alan. But what about Callie? Okay, he can see Callie because there's this angle here in the mirror. And this is where she would appear to be to him in the mirror. And same thing for Dell. Dell is able to be seen in the mirror. And the way you can tell this is, look. Follow this line here. 1, 2, 3, 4, 5 squares. 1, 2, 3, 4, 5 squares. Okay, what about Ellie? Can he see Ellie? No. Right? Because Ellie's 2 spots away. If I go 2 spots, if I follow this line, it doesn't go by the mirror. Okay, and then we want to say, who can Ellie see? So go back to the same simulator. You'll go back. You can click on Ellie. Who can Ellie see? And then Ellie's here, and try to figure it out. Like for example, Alan is 1 away, so if he goes this way, is there an angle between Ellie and the mirror and Alan to get to this point? No, I clicked on Ellie. Ellie cannot see herself in the mirror. But what about Alan? Yes, see? It goes right through there. You can see Alan. What about Dell, Callie, and Bill? Try to figure that out. So then next would be laser and mirrors. So you're going to try to hit the monkey. Go to the simulator. So here's your laser. Here are your mirrors. You're going to try to hit the monkey with the laser. This one, the ray optics simulation. So try to hit your ray source by using 5 flat mirrors. Add a screenshot when you're done. So if you accomplish it, get a screenshot, throw it in here. All right, next, an activity at home. If you can find a little portable small mirror, give it a shot. If you don't have one, then I guess you can't do it. Here, there's an Edpuzzle Mirage video. You'll watch that and try to explain in your words how a mirage works. Okay, for Lab 2, we're going to talk about a curved mirror. So if you click on the link here, there's another video or a simulator explanation of how a concave mirror image forms, and another one about how a convex image forms. So use that. So with a concave, select all that apply. Is your image upright or inverted? So upright or upside down. Is it bigger or smaller than the actual object? Is it real or virtual? And then do the same thing for convex. Okay, for procedure 2, there's a couple of demos here. You'll watch the demos and try to answer the questions again. So when close to the mirror, is the object inverted or so upside down, or is it upright? Is it real or virtual? Then you're going to try to figure out the magnification and put in where the focal point is. Alright, so now here, Optics Bench. This is where we're going to really get into you doing some of these calculations. You're going to measure the distance to the object and the distance to the image, and I want you to calculate the focal point. And then see if it matches what you get on the simulator. And then you're going to measure the height of the object and the height of the image and determine the magnification. So if we go to this link, we want to do a concave, inverted, real large image. So go down here, I'm going to make the screen larger. And I can move my object around. And I have my image. I can change my focal points. I can change the height of my objects. And I can change the type of lens. So if I have a mirror or lens. So if I go with my mirror here, I can move my object around. And I can see how it changes things. If I get within the focal point, I have that virtual image on the other side here. So, mess with those. See if you can get these calculations. If you look on the simulator here, it shows you the object's distance, the object's height, the focal distance. So when you do your calculations, see if you end up with the same number as they're giving you in the simulator. Okay, and then try to make your object, so upright, virtual, smaller image. So you can move to the other side here. It's upright, it's on the other side of the mirror, so we have an upright virtual image, and it's smaller. So then use that to determine the focal point, the object height, and things like that. Alright, so hopefully that helps get a little bit through the mirror part. And once you have the lab part done, go over to the homework, and you can start on homework 2 with curved mirrors. And the first part is, what do these terms mean? How do you calculate, determine magnification? What does the image look like? All right, and work your way through. And here again, we're going to use these to answer these questions. Alright, and in the next video, I'll start talking about lenses. So good luck, and have a great weekend.